Okay, now in this video, we will see search operation on the linked list. So since nodes in a linked list have no names, we use two pointers, temp2 that is previous pointer and temp1 that is current pointer in order to search our node. So at the beginning of the search, temp2 pointer is equal to null and temp1 pointer points to the first node where the head also points. And the search algorithm moves the two pointers together towards the end of the list. Let us see the code for it. So defining the search function. So we have our linked list class. In that we have defined search node function and we have to pass the position or the offset at which position we want to search the node. Okay. Now node star temp1 is equal to head. So our current pointer will point to head and previous pointer that is temp2 will point to null. So these are the two pointers which we will require. And length of the list variable list length is equal to 0 initially. Now if head is equal to null, that means there is no node in the list is empty. And after that, if your list exists, then you have to use your pointer to traverse the list and find out the length of the list. So in this case, we will take the temp1 pointer, current pointer. Okay. So while temp1 is not equal to null, what you have to do? Temp1 is equal to temp1 of next. So and list length plus plus. So for the first node, temp1 is not null. So you have to move to the next node by temp1 is equal to temp1 of next. Then if it is not null, move to the next node. Then if it is not equal to null, move to the next node. You have to keep on doing this until you reach to the null. Null kab aata hai? When you reach to the end of the list. And at that time, you will get the total nodes in the list and you will get the list length. And now, if your list length is less than node offset, suppose my list length is 5 and I want to search the node at 6th position or 7th position. That means you are going out of your list index, right? So in that case, you have to give the message element index out of bound or the element you are searching is not present in the list likewise. Okay. These are the two cases when your list is empty and when your element you want to search is not present in the list. Next, suppose your element exists in the list. Your list is of say 5 elements and you want to search element at second position, first position, third position, fourth position and so on. Okay. Suppose your element is position is 1. Okay. See one thing. I have assigned temp1 that is current pointer to head. And then if node offset is equal to 1 is equal to 1, see out head of data. It means what? Your search position is 1. That means you want to find out the data at position 1, node 1. Immediately you will find it out because your temp1 is pointing to head itself. So what you have to do in that case? Just see out head of data. वो head में जो भी data है उसको print कर दो, right? If your position is other than 1, in that case you have to run through our while loop. So what our while loop says? While node offset minus minus greater than 1, temp2 is equal to temp1, temp1 is equal to temp1 of next. Okay, that means while loop mein what happens in the while loop? Until and unless you reach to your position, okay, you have to shift your current pointer to previous pointer and then shift the current pointer to the next. Okay, and once the while loop execution is over, you will be at the position which you are searching for and you have to print that data. Let us see this through the graphics. So we have to find out the position, say node offset is equal to 3. This is the position. Okay, so we have our head is pointing to the first node. There are 4 nodes. We have 2 pointers, walking pointers. Temp1 is our current pointer. It is also pointing to the first node. It contains the value of 1000 which the head also contains, and temp2 is our previous pointer. It contains the null. Okay, now what we have to do? We have to delete the sorry, we have to search the node at position 3. As you can see, the code is same as that of your delete function. Okay, because in delete also we have to apply search algorithm first. Okay, so while node offset minus minus greater than 1, what is your node offset? 3. So 2 3 minus minus 2, 2 is greater than 1, condition is true. So what you have to do? Temp2 is equal to temp1. So temp2 में क्या जाएगा? 1000, which was previously the value of temp1. And temp1 में क्या जाएगा? temp1 is equal to temp1 of next. So temp1 of next क्या है? Okay, yet 2000. So it will contain a 2000. Now the loop execution is done. Come again, node offset minus minus, that means 2 minus minus. So 1 greater than or equal to 1. The condition is true. It will again go inside the loop. temp2 is equal to temp1. temp2 में 2000 था, वो temp1 में 2000 था, वो temp2 में डाला. So temp2 will contain 2000 address now, and it will start pointing to the second node. And temp1 is equal to temp1 of next. temp1 of next क्या था? 3000. So it will contain the 3000 now. Now temp2 is pointing to second node and temp1 is pointing to third node. Okay, now again we will go to the while loop. 1 minus minus, that means 0. 0 greater than 1. The condition is false, and now the temp2 and temp1 positions will not be updated. Loop will not execute because condition is false. Now in this case, what you have to do? See, temp2 is pointing to your second node and temp1 is pointing to your third node. temp1 is your current node, right? Current node is pointing to third node. What is your offset? 3. That means you want to search a node at 3. And temp1, current pointer is pointing to 3. So what you have to do? You have reached your search position. So you have to just print out temp1 of data. temp1 जो भी point out कर रहा है, that is the data you are searching for. So you have to see out or print your result. That is how you can search a node at any position. Okay, now with this we have covered all the operations that we can perform on a single linked list. So what are the advantages and disadvantages of using a linked list? So first thing is that insertion and deletion of elements can be done very efficiently and there is no wastage of memory. So these are the advantages with respect to your arrays. So we have seen the arrays and we have seen that while inserting or deleting in between element from the array, there are a lot of shift operations involved. Here we don't have to shift anything. Rest of the elements will be intact at their own position. We just have to change the pointers and we can easily and efficiently do our insertion operation, deletion operation and so on, right? And as linked lists are generated dynamically, every node is created when we have to add it, okay, dynamically. So there is no wastage of memory. In array, we have to declare an array with its size beforehand. And suppose we declare an array of 100 elements and we are using only 5-10 elements. So rest all element space will be wasted. In linked list, that is not the case. We keep on creating the node as and when required. Okay, now what are the disadvantages of the linked list as compared to the arrays? The first disadvantage is that linked list or linked organization does not support random or direct access. Now suppose I have created a array of 100 elements, right? And I want to access the array element at 98th position. So I can very easily access A of 98 and it will give me the element, right? But this is not possible in case of linked list. Suppose you have a linked list of 100 elements and you want to search the 98th element. You have to traverse through the first element up to the 98th element. Okay, direct access or random access is not possible. You have to traverse all the elements to reach to the 90th element. Okay, and the second disadvantage, each data field should be supported by a link field, a point to the next node. So thus requires more memory. See, in array, suppose you want to store 100 integers, right? So you suppose every integer takes 4 bytes. So you will require 400 bytes of consecutive memory. And that is the only memory you will require because you have to store the element directly. But here you have to store the element also and the link field also. The link field means your pointer field, and your pointer field contains the address of the next element. So to store every element, you have to store its associated link also. So the memory required will be more in this case to store the links. So these are the advantages and disadvantages of linked list with respect to array. What are the different other operations other than what we have seen till now that we can perform on linked list? So we can count the number of nodes that we have done to find out the length of the list, right? Then you can display reverse list also. You can have the inversion operation with second list or without the second list. You can invert the whole list by taking the help of one more list, second list, or without the help of second list. Then you can concatenate two lists. You can sort the elements in the linked list. You can merge two sorted lists, and you can separate a linked list into linked list also. So these are some of the basic operations that we can also perform on the linked list. Thank you.